Question 1 is a 0.50 kg cart moves on a straight horizontal track. The graph of the velocity versus time for the cart is given below. Indicate every time t for which cart is at rest. Now the cart will be at rest when, oh, 1 minute. Now the cart will be at rest when its velocity is 0. So that means at this point where that is at t is equal to 4 second, and its velocity is 0 at this point also. So this is t is equal to 18 seconds. So 4 second and 18 second for this part. B part is indicate every time interval for which the speed of the cart is increasing. So see, if we check the graph from the beginning, so its speed, initial speed is 0.8, and then it start decreasing. It decreases up to 0. It decreases to 0 up to 4 seconds, and then it start increasing in again. After that, it start increasing in the opposite direction. So that means from 4 to 9, this is 9. Its speed increases and then again start decreasing, become constant, and then again start decreasing and reduces to 0 at t is equal to 18 second. Then from 18 to 20 again it start increasing. So that means the speed of the cart increases from 4 to 9 second and then 18 to 20 second. Then the next one is we need to determine the horizontal position of the cart at t is equal to 0.9 second if the cart is located at x equal to 2 meter at t equal to 0. So for that we can use this equation, kinematics equations of motion. Delta x is equal to vxt plus half at square. So here the initial speed of the cart is 0.8, time period is 9, and acceleration we need to calculate. So from here we will calculate the acceleration for this line up to t is equal to 9. So you can choose any 2 points on the graph. So I'm choosing this point and this point. So its slope of the graph gives the acceleration. So it is 0.8 minus 0 divided by 0 minus 4. So it comes out to be minus 0.2 meter per second square, right? So here minus 0.2 into time is 9 square. So here so after calculation we will get this value as 0.9 meter, minus 0.9 meter. Now we can write delta x as x minus x naught equal to minus 0.9. So from here x is equal to x naught minus 0.9. So x naught here is the position at t is equal to 0. So that position is 2 meters. So 2 minus 0.9, so it is 1.1 meter. Now let's move on to the next part. Let me first clear this one. So the next part is on the axis below, sketch acceleration a versus time t for the graph of the motion from 0 to 25 seconds. So now from 0 to 25 seconds. So let's move on to the previous graph also. So see, from 0 to 9 second, the velocity basically the acceleration of the velocity time graph, acceleration is the slope of the graph, right? So from 0 to 9 second, it has a constant acceleration. If you remember, we calculated in the previous part, it is minus 0.2. Now velocity is constant from this is 12 second, from 12 to 18. From 12 to, sorry, this one is 17. From 12 to 17 second, the velocity is 0. Velocity is constant, so its acceleration would be 0. And then again from 17 to 20, it will have a constant positive acceleration, and then again 20 to 25 its speed is constant, so it will have a 0 acceleration. So now let's move on to the graph here. So let's plot the graph. So from 0 to 9 second, its acceleration is minus 0.2, this one, and then after that uh, it will be a plus 0.2 from um, this region to it goes up to 7 up to this point, up to 12 second. And then The after that the velocity is constant from 12 to 17 seconds, so its acceleration is 0. So here 12 to 17 seconds, and then again it has a its velocity increases at a constant rate, so the acceleration is constant, and that acceleration we need to calculate. So let's move on to the previous graph. So yes, so here for this one, now for this region, let's find out the slope of this graph gives the acceleration. So here let's choose this point. So this point is 0.8. Let's choose another point as 0. So 0.8 minus 0 divided by 20 minus this is 18. So 0.8 divided by 2, which is 0, 0.4 meter per second square. So it has a constant acceleration at this region. So here moving on to the graph. So 0.4 meter per second square, that is here from 17 to 20 seconds. This one. Yeah. And then after that again its acceleration becomes 0 from 20 to 25 seconds. Yeah. So this is the acceleration time graph. Now the next part is from t equal to 25 seconds until the cart reaches the end of the track, the cart continues with the constant horizontal velocity. The cart leaves the end of the track and hits the floor, which is 0.40 meter below the track. Neglecting air resistance, determine each of the following. The time from which the cart leaves the track until it first hits the floor. For that, we can use this, we need to find the time period. We will use the kinematic equation S is equal to ut plus half at square. In order to calculate the time, we will consider the vertical motion. So the vertical motion, in vertical motion, the initial vertical velocity is 0. So from here, it becomes S is equal to half at square, and from here t is equal to root 2s by a. And so here a is equal to a will be equal to the acceleration due to gravity. So a is equal to g. So 2 into the s is 0.40. So yeah, so the s is 0.40 divided by g. G is 9.8, or you can also use 10. So any value you can use. So then from here time comes out to be, if we solve it, so after calculation we'll get the value of time as 0.29 seconds. Now the second part, we need to calculate the horizontal distance from the end of the track to the point at which the car hits the floor. So we need to calculate the horizontal distance. For that, we can use this equation. For horizontal distance, x is equal to vx into t. Horizontal, for that I am considering the horizontal motion. So horizontal motion is a uniform motion, so its acceleration will be 0. So I'm using the same equation. So this becomes 0, so it becomes x into uxt, vx into t. Vx is given as the initial velocity, so that was 0.8, and the time is 0.29. So after calculation, we will get here the horizontal distance as 0.23 meter. Now the third part is kinetic energy of the cart immediately before it hits the floor. So for that, so the kinetic energy, for that we will use the law of conservation of energy. So kinetic energy at the bottom will be equal to kinetic energy at the top plus the potential energy at the top, because at the top it has a gravitational potential energy. And why it has a kinetic energy at top? Because initially it was moving with a certain speed, which is 0.8. So that's why it has the initial kinetic energy also. So here now we will substitute the values. So it is half mvxk plus mg y So let's say y is of distance 0.40. So half into mass is 0.50 and speed was given 0.8 square plus again mass is 0.50 into g is 10 and y is 0.40. So here after calculation, yes, after calculation we will get the value of mg. Oh, g I didn't mention. Oh, I mentioned g as 10. So you can even use 10 or you can even use 9.8. So here I've written 10. So let's use now, for now, let's use 10. So if we solve it, we get the value of kinetic energy at the bottom as 22 joules.